Okay, pre-calc, let's take a look at some ways to find areas of triangles and learn the laws of sines. So the first thing we want to go over, okay, is the basic area of triangles. And this is something you probably learned back in grade school. Okay, so if you have a right triangle that looks like this, okay, with a 90-degree angle in the corner, the area of the triangle, okay, would be base times height times 1/2. Okay, so we've got area is 1/2 base times height, and the base and the height are both on the triangle. Okay, but sometimes you have a triangle maybe like this. Okay, so we know that the base is right there. The height would be from this vertex, okay, perpendicular down to the base. The height is not one of the sides of the triangle, but rather just a segment inside. You could also have one of these obtuse triangles like this. So we've got the base, okay, but the height would be a perpendicular distance, okay, down to the base. So the height would, again, be outside the triangle, not a leg or a side. Okay, this is good to know, or good to use when we know the base, okay, and when we know the height. Then you should do 1/2 base times height, but it has to be perpendicular. All right, here's an even better formula. Sometimes when you're looking at a triangle, sometimes we know side angle side. Okay, so what that means is we have two sides and then the angle in between them. So if we have triangle ABC, something like this, across from angle B is where you would find side B. Across from angle C is where you would find side little c. So if we know this side and we know this side, and then the angle has to be between them. Okay, so if we know angle A, here's what the law of sines says. The area is 1/2 the side, so B times C times the sine of angle A. Now, you can do this in a variety of ways. Okay, maybe we know these two sides. So let's just pretend here, if we know side little a, we would do area is 1/2 side A, side B, and then what angle would we have to take the sine of? It has to be the angle in between them. That's right, it would be angle C. So let's not worry about the letters so much. Let's just make sure when we're looking at the triangle, we have two sides and the included angle. So this is great to use if we know two sides, and the included angle. And included means the one between them. Okay, there's one more formula for the area of a triangle, and this is Heron's formula. Heron's formula is when you have a triangle, and let's say we know all three sides. Okay, let's say we have side A, side B, side C. We don't know any angles. We can't use this formula, and we don't know if any of them are perpendicular. So this would be a great formula to use. The first thing we have to do, though, is calculate something that's called a semi-perimeter. Oops. So semi meaning half, okay, and then the perimeter of a triangle would be A plus B plus C. So the first thing you'd want to do is calculate the semi-perimeter, and then we're going to use that in the area formula. So here's the area of the triangle. It is a very long square root symbol. And the first thing you do is you take that S, you take that semi-perimeter calculation, you put it in the radical, and then we're going to multiply by the semi-perimeter, but we're going to subtract off the first side, S minus A. And then we have to do that with the other side. So then it's going to be S minus B, and then multiply by S minus C. Notice you write S 4 times, once by itself. Okay, make sure that radical is nice and long. This is a great calculation to do if you know all three sides. Okay. I just want to make sure you guys understand these last two here are not for right triangles. They're for any triangles. 1/2 base times height. You have to know the perpendicular distance. Okay, that's why these are a little more powerful. Let's try some examples. Find the area of a triangle with this information. So the first thing you should do is draw a picture and put an ABC on it. And it doesn't matter where you put ABC as long as we get this information in the right place. So side A would be across from angle A. So this side over here is 8. Side B is 6. So go to angle B, you go across the triangle, and that side down there would be 6. And they're telling me angle C is 30 degrees. Oh, perfect. Okay, I've got two sides and the included angle. Okay, so we're going to use this formula here with a sign in it. Area is 1/2 8 times 6 times the sine of 30 degrees. Okay, so let's go ahead and calculate this. Half of 8 is 4. 4 times 6 is 24 times the sine of 30 degrees. Oh, now normally we would just type this in our calculator, but I don't think we need a calculator because this is an angle that we know the value of. Because the sine of 30 degrees is how much? Yeah, it's 1/2. Half of 24 is 12 units squared. Okay, now this formula can work for any triangle. If we happen to have an angle that wasn't 30, we would go ahead and type that in. So let's just show you what that would have looked like. We would do 1/2 times 8 times 6 times the sine of 30 degrees, and then the answer, of course, is 12. Okay, make sure when you're doing calculations like this, since we're hitting the side button, let's just make sure our mode is in degrees. I guess this was 30 degrees. Okay, let's go to the next one. Find the area of a triangle, okay, whose sides are 4, 5, 7. 4, 5, 7. Okay, does this make a triangle? I just want to make sure you guys remember a rule from geometry. Two sides added together have to be more than the third side alone. Are 4 and 5 more than 7? Yes. Okay, you can't have a triangle where these are smaller than 7. So if this was 1 and this was 2, they wouldn't even reach. If we swung this one down, it would only go 1 unit there, 2 units here. Do you see how it's not enough? Okay, just always remember, two small ones have to be bigger than 1. So to find the area of this triangle, which does exist, let's use Heron's. The first thing we'll do is calculate the semi-perimeter. Semi meaning half, and then the perimeter of this would be 4 plus 5 plus 7. Let's see, 4 plus 5 is 9, plus 7 makes 16, and half of 16 is 8. So the semi-perimeter is 8. I need to use that in my area calculation, right? So the area is, first we write down 8. Then we take turns. So we're going to do 8, subtract 4, then 8, subtract 5, and 8, subtract 7. Okay. You could type this in just as is, or you can clean it up by hand a little bit, since these are all nice numbers. 4 times 3 times 1. Okay. Maybe I'll type it in now. So we have the square root of, and now we've got 8 times 4 times 3 times a 1. Okay. And the area is approximately, let's do some nice rounding here. Since that's a big number, we're going to round it up to 9.80 units squared. Okay. A couple things I want to make sure that you're noticing here. Okay. Do you see how nice and long the radical is? Have to make sure that the radical covers all your calculations. So draw a nice long square root symbol. Okay, and then right here, okay, we have to round. Okay, so we must round this one up. Okay, so make sure you round appropriately to 2 places. Now that we're doing calculator things, we have to make sure we do good rounding. Okay, let's take a look at a couple more things. Okay, this was kind of fun. Find the area of a segment. This is the first time we're doing a segment, so let's just make sure that we know what a segment is. Okay, a segment, okay, is a piece of a circle between a chord's right here, and then the arc, which is right here. So a segment is between an arc and a chord of a circle. It doesn't touch the center at all, it's just this piece right here. Okay, so that is what a segment is. It's not a sector, and it's not a triangle. But we are going to use those two shapes to figure this out. So here's the setup for something like this. Okay, so what we're going to do is figure out what the area, okay, of this sector is. Okay, but that would be way too much, wouldn't it? That would be this whole thing. Then we're going to subtract the triangle. Okay, so subtract the triangle, subtract that much away from it, and then what we'll have left, okay, is that segment. Then you'll have that much area left. Okay, so that's our plan. So let's finish reading the problem so we get some information. The circle has a radius of 8 feet. Okay, so this side right here is 8 feet, and that one right there is 8 feet. And the central angles touch the center of a circle, and that's 70 degrees. Okay, so how do you figure out the area of a sector? What's that formula? So we're going to have 1/2 times 8 times 8 I'm sorry, hang on. This is not the sector. The sector is the piece of the circle. It's a fraction of the circle. So we're going to have 70 degrees out of 360. And then the area of an entire circle would be pi r squared. Okay, I was talking about the triangle area. The area of this triangle, okay, which is 8, 8, and 70, would be 1/2 8 times 8 times 70 degrees. Okay, and all of that together is going to make the area of the segment. Okay, so once you get your setup, I'm just going to go ahead and type all this into the calculator at once. Okay, let's see. We don't want to round and then chop and then round and then chop and then keep losing accuracy. So let's see, maybe I'll use that fraction command. 70 out of 360 times pi r squared. Okay, so I've got the area of the sector typed in, minus the triangle. 1/2 times 8 times 8 times the, oh, I forgot sine. The sine of 70 degrees. That's our new formula right there. And survey says we've got 9.03, and the units are feet squared. Okay, we're going to now take a look at the law of sines. Okay, the law of sines is a very useful formula here to figure out triangles because it's good for any triangle. So it's more powerful than Pythagorean theorem or SOHCAHTOA because we don't have to have that right angle. Okay, it's good for any triangle. So let's just go ahead and label this triangle A, B, C for the angles. Oh my goodness. Across from angle A would be side A. Angles are capital and the sides are small. Across from angle B would be side little b. And across from angle C is side little c. Okay, so here's how the law of sines works. If you start with angle A, you would do the sine of angle A divided by his side little a. And that's a fraction. But we need an equation. Okay, so we're going to equal that to another fraction. We'll start with sine of angle B, and then we'll divide by little b. So you only need to have 3 values, and then we could solve for the 4th by cross multiplying. Okay, so if we had this angle, we had this number, we had this angle, we could find this variable. You would need 3 out of the 4. Okay. Now that's not the only ratio you can make. You only need 2 to form the proportion. But there is another fraction you could make. it would be sine of angle C divided by side little c. Now you would never make all three of these. Maybe you would make these two and then cross multiply. Or maybe you would make these two and then cross multiply. Okay, so let's just put a note here. Only make two ratios to solve. Okay, but that's just the setup that you would use. Okay, let's do an example here. So let's draw a triangle and let's put angle ABC on it so we can get these values in the right place. Okay, so we've got side little a, which is across from angle A. So this side is 8. Angle A is 36 degrees. Angle B is 48 degrees. Okay, when it says solve a triangle, solve means to find all missing values. Okay, so that could be the sides or the angles. There's 6 parts to a triangle, and they just told us 3 of them. Okay, so let's make a nice little organized box. What are the 3 pieces of information that we don't know yet? We need the measure, please write an M, measure of angle C. That's one of them. We don't know side little b, and we don't know side little c. Okay, so here's our box of answers. Let's make a nice organized box. I need to find all 3 of these things to solve the triangle. And I'm going to use the law of sines. Okay, so if I just look at this, I see that these two go together. The sine of 36 degrees, okay, that's sine of angle A, goes with side little a, which is 8. So you go across the triangle. And now we need another ratio. And I'm going to use the 48 because that's the other value given. So let's do sine of 48 degrees, and that would go with side little b. Okay, let's go ahead and cross multiply here. B times the sine of 36 equals, cross this way and make the right side, 8 times sine of 48. Right, notice I'm not picking my calculator up at all. I'm going to do all the work, and you just pick it up at the very end. You don't type this in and chop off answers and work with rounded decimals. To get the value of b, we would divide by the sine of 36 on both sides, and b is equal to that calculation. All right, it's finally time to take out your calculator because we're at the end of all the algebra we could possibly do on paper. We're going to do 8 times the sine of 48 degrees, divide by sine of 36 degrees. Okay, and what do you get for little b rounded to 2 places nicely? I hope you got 10.11. Okay, so let's fill that box in, 10.11. So we've got one of the missing values. Okay, let's see. We have to find angle C and side C. So if I start making my next proportion, I'm going to just start with sine of 36 again over 8. Okay, if you have your choice between a nice number and then a decimal one that was rounded, pick the whole number. Things will just come out a little bit better. Okay, but now, oh no, these are 2 unknown values. I can't work with 2 unknowns. Is there any way for us to figure out the measure of this angle? Well, we know a triangle has 180 degrees, right? So can you please figure out the value of that angle right there? If we just subtract these two from 180, we're going to get 96 degrees. 96, let's fill that in. Measure of angle C was 96. Okay, so we just do subtraction from 180. Now I can continue making my proportion. Sine of 96 degrees is equal to side or over side little c. Let's do as much algebra as we can before we pick up the calculator. Okay, so to make a proportion, you cross multiply here. C times the sine of 36 equals 8 times the sine of 96 degrees. Notice you put the constant in front so it doesn't look like it's part of the of. Okay, the angle's just 96. Let's divide both sides by sine of 36. Okay, and now it's calculator time. So please type this in and tell me what you get. Okay, so 8 times the sine of 96 divided by sine of 36, and we get 13.54, rounded nicely. And that's our third and final value for solving this triangle. Okay, please make an organized box of the 3 missing values. Okay, let's do another one. Solve this triangle using the law of sines. All right, let's go ahead and make a triangle. I'll just call it ABC so I can see what we're working with here. Okay, side C is 8. Side C is 8. Angle A is 42. Side B is 38. Okay. So the 3 missing values we would have to find. Let's make a box here for those. Side little a. Across from angle B, we need side little b. And then, of course, measure of angle C. Measure of angle C. So out of all of these, there's one that we should be able to tell right away. Right away, we should be able to figure out what the measure of angle C is, because a triangle has 180 degrees. So 180, subtract 38, subtract 42, and what do you get? So the measure of angle C is exactly 100 degrees. 100, okay? I'm going to put an equal sign there because it's exact. These guys are going to be rounded, so I'm going to put approximate symbols for those. Okay, let's see, which one can we go for first? I'm definitely going to use the 100 and the 8 because those are 2 nice numbers that I know. So sine of 100 degrees over 8. And now let's go for side A first. So we'll do sine of 42 degrees over side little a. Let's do as much work on paper as we can. When you cross multiply, you make a left side, a times the sine of 100, and then you make the right side, which is 8 times the sine of 42. It doesn't matter which way you cross. These can be on either sides. We're both going to divide by sine of 100. Okay, and let's see. What is the answer for side little a? We have to do 8 times the sine of 42, and then divide by sine of 100. 5.44. 5.44, approximately. We had to round that one up. All right, and now we've got one remaining side to find. I can go ahead and put 5.44 right there. The last value would be side little b. Now let's see. I know I have to do sine of 38 degrees, which goes with b. And now we have a choice. Should we use the angle 42 with that chopped decimal, or should we use 100 with 8? Okay. Whenever I have a choice, I always pick the numbers that are nice and whole, the exact values. I'm going to do sine of 100 over 8. And my answer will just get a little more exact, a little more precise, because I'm not using an answer that I chopped off. This is the complete answer. So let's cross multiply. B times the sine of 100 equals 8 times the sine of 38. Divide both sides by sine of 100. Okay, and b is approximately equal to what? 8 times the sine of 38, divide by sine of 100. What did you get? 5.00. Okay, that's how you solve a triangle. Let's take a look at just a couple story problems here and see if we can figure out what the correct formula is to use. So while snacking on a bag of Doritos, Jason is overcome with the need to know how big the average Dorito chip is. Okay, he measures the three sides of the average chip, and he finds that they're 4.5, and 4.8 centimeters. What is the area of this Dorito chip? Which formula would be correct for finding the area here? Yeah, we're going to go with Heron's. Okay, we're going to go with Heron's formula. The first thing we have to do, of course, is calculate the semi-perimeter. So 1/2 of 4 plus 4.5 plus 4.8. So what is the semi-perimeter for this triangle? Semi-perimeter is 6.65. Okay, now that's exact. That's not chopping anything off. I'm going to use that. Okay, I'm going to use this entire value. I'm going to use the entire value so that I have more accuracy in my answer. Don't round that to 6.7. Okay. All right, the second step will be to calculate the area. The area is big square root, and we start with the semi-perimeter. And then we have to do semi-perimeter, subtract one of the sides. Semi-perimeter, subtract off the second side. Semi-perimeter, subtract off the final side. Okay? Is this a good setup here for area? No, can make sure that you have that radical covering the entire calculation. Okay, and let me show you, when you do this in your calculator, when you push the square root button, the square root of, the radical sign should keep covering everything we type. So if we do 6.65, okay, do you see how it just keeps extending? That's what we have to do. 6.65, take away 4. 6.65, subtract off 4.5. 6.65, subtract off 4.8. Okay, close parentheses and round it to two places nicely. Okay, Jason, what is the area of that Dorito chip? 8.37 centimeters squared. What an interesting question. Makes me hungry for some Doritos. Okay, last one. Find the angle between the rows at town A. Okay, so this is the angle I'm interested in finding. Angle A is across from this side, which is 10. And they did give me some more information. Okay, I know that this angle is 42, and it's across from side 8. So let's use the law of sines. Sine of angle A over 10 equals sine of 42 over 8. Okay, let's go ahead and cross multiply here. 8 times the sine of A equals 10 times the sine of 42. Let's divide both sides by 8. Sine of angle A. This problem seems a little different. Can you divide by the sine? No, you don't divide by sine. How do you find the measure of an angle? Yeah, if you want to find the measure, you have to go backwards. You have to do inverse. Okay? So what I would have to do here is sine inverse of this stuff. I'm going to type it all in at once so I don't lose any accuracy. So I'm going to do second sine inverse of this, which is 10 times the sine of 42, divided by 8, close the second set of parentheses, and the measure of angle A is approximately how much? 1.76. Make sure you say degrees. Okay? Great job, Pre-Kelly.